Hi everyone, this is Mrs. Pagan, and in today's lesson we're going to talk about graphing quadratics in vertex form. Alright, first a quick lesson on what it is a quadratic. A quadratic is a U-shaped graph. We call this a parabola. So this is going to be our focus for the unit. Remember that parabolas or quadratics could be written in three different forms. We have vertex form, we have intercept form, and standard form. In vertex form, we see the vertex. In intercept form, we see the x-intercepts. And then in standard form, we don't see much, so calculators are valuable in standard form. So when it comes to quadratics, the focus right now for today's lesson will be on vertex form. So that right there is a general vertex form, and we'll talk about what each part equals. All right, so in vertex form, when you have a function in vertex form, we can go ahead and find the vertex by looking at what is inside the x with what is outside with the y. So notice that here it's x minus h, but our vertex is h, and then it's positive k, and it is positive k. So it's the opposite of x that we are seeing. So that will be the vertex. If a, the number in the front, is positive, then we know it opens up. So the graph will look like this. And we know that the location, the location will be a minimum because it is a low location. If a is negative, then the parabola is going to open down, kind of looking like this, and we know that the vertex is going to be called a maximum because it's at a high location. Now there is this line called the axis of symmetry, sometimes known as the line of symmetry. It is basically what it will do is split the graph in half. So in this graph you would have a axis of symmetry going through the vertex. So that would be our axis of symmetry. That's what it looks like. It is a dotted line because it doesn't really exist, but we value it because it cuts the graph in half. And all of the axis of symmetries will be x equals the number that you have. So whatever the x values in the vertex, it'll be x equals 3, x equals 4, something like that. And I'll show you some examples of those. All right, let's go ahead to example 1. In example 1, they're giving us an image. It says label the picture with its vertex, how it opens, and also its axis of symmetry. So let's get started with 1 and 2. Just zoom out a little bit. Oh, here we go. All right, that's good. All right, so in example 1, we know that the vertex in this case is the lowest spot. It is at -2, -1, so that will be our vertex. And then we recognize that the parabola is opening up. So we are going to say that it opens up, not down. And the axis of symmetry is the line that goes through the vertex and cuts the graph in half. This is an x equals line, and since we are going through x equals -2, this will be at x equals -2. Now recognize that the vertex and the axis of symmetry have something in common. Both x's are -2 because the axis of symmetry goes through the vertex at that location. Let's try this again. Here's a different graph. I can already see the vertex, and that's at 1, 2, and up 1. So the vertex is at 2, 1. This is opening down. It's a parabola that's facing down, and the axis of symmetry will be going through the vertex, and it looks like it's at x equals 2. It's always going to be x, and notice once again that the x value on the vertex matches the axis of symmetry. Always matches that. All right. Let's go on to the second page. Now what we're going to do is, given an equation, we're going to be able to answer some of these questions. So I'm going to tell you exactly where to look for each one. To find the vertex, what we do is we look at what's inside with the x and also what's outside. We always take the opposite of what we see. So notice it's -4, but we always take the opposite. So that's going to be positive. But then we take this 2 as it is. So the vertex is at 4, 2. When it comes to opening up and down, we look at what is in front of the parentheses. So right there, there is no number there, but we know that it's a 1. And since 1 is positive, we know that it opens up. And then the last thing is the axis of symmetry. We know that they have to match with the x that we see in the vertex, so we are going to just say it is x equals 4. All right, let's go on to the next one. The vertex, once again, is going to be the opposite of x and the same as y, so it's going to be -3, -1. Opposite of positive 3 is -3, same, drops down. We are going to go ahead and look in the front of the parentheses to see what's happening. It's a negative. Negative means it opens down. The whole thing has been just pointing down. And then the axis of symmetry, we're going to grab that once again from the vertex. Those are related. So it's going to just be x equals -3. All right, now let's look at the vertex again. We are looking at the value on the inside and outside. There's no number behind this, so really that's 0. And here it's -5. It drops down. I am going to look at the number in the front of the parentheses, not inside, but in the front. It's positive, therefore we know it opens up. And the axis of symmetry is going to match the x value of our vertex, so we know it is going to be x equals 0. All right, I hope that was helpful. Now we're going to go into a little bit more challenging problems where we're going to utilize our calculators to help us out. All right, let's look at example 4a. What we're going to be doing in example 4a is using our graphing calculators to help us out. So we're going to use this graphing calculator I have here. And I'm going to go to my y equals and clear whatever I have. And I'm going to type in the equation. So the equation was x plus 3, close it up, raised to the second power. I'm going to come down from there by just pressing the right arrow. Minus 2. And I'm going to graph it. Let's do zoom 6 just in case your calculator is not on a 10 by 10 screen. And so that's what our graph looks like. We can tell that it's opening up. We can tell there's a vertex here. We can also tell the vertex by looking at the equation. And then we can find some left and right points. All right, so let's do this. By looking at it, I can tell what the vertex is. This is the opposite of the 3, so -3, -2 is the vertex. We also know, because what's in front of the parentheses is positive, that this opens up. And we know that the axis of symmetry is once again the x value of the vertex. So all we need is a point to the left and a point to the right. So let's go to our table, second graph, and get some points. Now we said that the vertex was at -3, -2. So I'm just going to grab 1 point to the left of that and 1 point to the right. So left would be smaller. So I'm going to do -4, -1. That would be left of that point. And to the right of that point would be -2, -1. And I just need 3 points to graph my U shape. So let's plot these 3 points. We have the vertex at -3, -2. That's our vertex. I'm going to label that vertex. And then we have another point at -4, -1, and another one at -2, -1. And because I know it looks like a U, I'm going to make it as U-like as possible. So here's the curves on that one. So I hope that was helpful. Now let's go ahead and do example B as well. So we know once again that the vertex is the opposite of the x and the same as the y. So opposite of -4 is +4. The 1 drops down. I'm looking at the value in front of the parentheses. It's negative, therefore it opens down. The axis of symmetry is going to come from our x value of our vertex. So x equals 4 must be written as a line. And then we're going to find 2 points to the left and right of that. And we'll use our calculator to help us out. So I'm going to go to the calculator. And I'm going to go to y equals again and put my new equation in. So it's negative, open parentheses, x minus 4, close my parentheses, raised to the second power. And then it's going to be +1. So let's just see what the graph looks like. There it is, opening down. All right, so we can even see that the vertex is at 4, 1. So that's kind of cool. Now we're going to grab a couple points to the one left and one right of that. It looks like it's at 3, 0, 3, 0, and 5, 0, but let's confirm. Second table. So I'm going to go to my vertex. My vertex is 4, 1. Oh, there it is. There it is. I see it. 4, 1. Stop! Oh, I went too far. That's what happens sometimes to me. That's okay. I'll just find it again. There we go. One more time. All right, so here's 4, 1. So point to the left would be 3, 0. Point to the right would be 5, 0. So we have left is 3, 0. Right is 5, 0. And then we can plot our points. So there's one at 4, 1, 3, 0, 5, 0. And we know it is a curve parabola going down. And I'm going to go ahead and draw the axis of symmetry, which is a dotted line. Ooh. Hold on 1 second. Just messed up a little bit. I have to delete and then bring it back. As you know, this happens in my class as well. I have the touch screen on. There we go. So here's the axis of symmetry. It's a dotted line because it really doesn't exist, but we like it because it cuts the graph in half. And we forgot to do it in example A, so let's do x equals -3 as well. Draw our dotted line. These are our axis of symmetries. And that is all I have for you guys for today's lesson. Great job. I hope it was helpful. If you need to watch it again, go ahead and do so, pausing it when you need it. Have a great day. Bye, guys.